Good morning. We will start Polynomials Session 4. So in previous session I had given you two homework, that is a long division method which was a worked example answer. Anyhow you can check in your textbook itself because it is already a worked sum. Next I had given you another sum for long division method from the exercise where you already know that the remainder is 0 but still you have to perform that by a long division method. So they are simple enough. Now here the thing is there are small corrections what you have to make in yesterday's session. Question number 1 from the exercise, first one yesterday with what we started. So in the first main, that is fourth sub question x plus pi, the question was find the remainder when a polynomial is divided by x plus pi. So as per the rule, x plus pi is equal to 0, x is equal to minus pi we substitute. So when we substitute minus pi in place of x here, in yesterday's class, I have not written minus here. Instead, I have written 3 of pi. So I have missed that minus sign. So here also I got plus 3 pi. This is the right answer. Wherein for yesterday's what we have done, please do the necessary changes. Second one, third question. Check 7 plus 3x is a factor of 3x cube plus 7x. With all we do, we get the 0 as minus 7 by 3. Yes. When we substitute in this, the whole equation, 7 cube is 343. Instead, I have written as 243, which is wrong. But we got the answer correct because by solving I knew that this should be the answer. I arrived at the answer right, but please make the necessary changes. 7 cube is 343, not 243. I appreciate my students who called and made me aware that I had gone wrong in these two sums and made the necessary changes. Yeah, very well done. So this shows that you are actively participating in the class, right? Good. So teachers also are human beings, children. So we can also make mistakes. So yeah, please do this necessary changes. We will start with the next exercise. So we'll begin with the next exercise. Determine which of the following polynomial has x plus 1 as a factor. So to understand this question, which of the following polynomial has x plus 1 as a factor? That means, suppose if I give you two numbers, say 225 and 243. And I have to check whether 5 is a factor of 225 and 243. What do I do here? I simply divide this by 5. So here 5 is something say as x plus 1. 225 and 243 are nothing but the given polynomials. So when we divide this, 5 4s are 20, 2 remainder, 5 bringing down, 5 5s are 25, remainder is 0. 243 when I divide, 5 4s are 20, 4 remainder, 3, 5 8s are 40, 3 remainder. Now here see, we got 0 as a remainder, we got 3 as a remainder. Since we got 0 as a remainder, can I say 5 is a factor of 225, wherein 5 is not a factor of 243. This tells us that if a given polynomial has a particular expression as a factor, that means the remainder should be 0. How do you know that remainder is 0? By remainder theorem method when we apply and do it. So if you get remainder as 0, the given term is a factor of a polynomial. If something is left as a remainder, then it is not a factor of the polynomial. Very clear? So let's start with an exercise. This was just for your understanding to make the concept very clear. So in first main, yes. Today what I do is I'll just write the homework part there so that till the end of the session homework will be there. And children, what you can do is, since the homeworks are from textbook only, you can very well check the homework answers from the back answers what they are given behind the textbook, what answers are there. Check with that. If in case you get a right answer, put a tick mark. In case you get a wrong answer, try it once again. Even then you are not getting it, please call me so that we can address your doubt in the next session. So here in the first meet, you are supposed to take the first one as homework and second one as homework. That is, at the first question, first submain and second submain as a homework. Please mark it. So we'll start with third one. So third question is x. I'll write off, let p of x is equal to x raised to 4 plus 3x cube plus 3x square plus x plus 1 factor of, what is the factor given? No, let's not write as a factor because the factor is not given. We need to check it. Let's check the question. X raised to 4 plus 3x cube plus 3x square plus x plus 1. So according to the solution, 0 of x plus 1, we equate this equation to 0. This implies x is equal to minus 1. We just transpose it to here. Then p of minus 1 is equal to, wherever x is there, let's substitute 1. So this is minus 1 raised to 4 plus 3 into minus 1 raised to 3 plus 3 into minus 1 square. It is plus 1. Directly I will write minus 1 because x is minus 1 plus 1. Negative number raised to even power, answer is positive. So this is plus 1. Negative number raised to odd power, answer is negative. So this is minus 3. 3 into minus 1 is minus 3. Negative number raised to even power, answer is positive. So 3 into 1 is plus 3. Then we have already here plus 1 minus 1 will cancel by itself. Plus 3 minus 3 also will cancel. What is the answer? 1. Remainder is 1. So if remainder is 1, that means x plus 1 is not a factor of this. This implies, I can say, r of x is not equal to 0. Okay? Remainder is 1 here, what we have got. P of 1 minus 1, write off once again here. Therefore, by factor theorem, complete the statement. X plus 1, right? X plus 1 is not the factor of the given polynomial, that is x raised to 4 plus 3x cube plus 3x square plus x plus 1. That's the answer. Is this very clear? So it is not the factor. Now similarly, let's check with the fourth one. So fourth one, what's the equation? Let p of x is equal to x cube minus x square minus 2 plus root 2 of x plus root 2. Now children, see here, since you have this as minus of a binomial term, if you want, you can split that. It is easy for calculation. So I can rewrite this again if you want as x cube minus x square minus x into 2 is minus 2x minus x into plus root 2 is minus root 2x plus root 2. Again the same thing I will write here. 0 of x plus 1 is equal to, equate the equation to 0, as simple as that. This is equal to, x is equal to minus 1. P of minus 1 is equal to, wherever we have x, let's substitute as minus 1. Minus 1 cube, minus in the question, minus 1 whole square, minus 2 into minus 1, minus root 2 into minus 1 plus root 2. Too many minus 1. Okay. Minus raised to negative power, answer yes. Minus raised to odd power, answer is negative. So minus 1 itself here. Minus 1 raised to even. Answer is plus. Plus into minus. Minus 1. Minus 2 into minus 1. Plus 2. Minus 2. Minus root 2 into minus 1. Plus root 2. Plus root 2 as it is. So minus 1 is minus 2 plus 2. Now see here root 2 and root 2. Coefficient of root 2 is 1. Coefficient of root 2 is 1. 1 root 2 plus 1 root 2 will give you 2 root 2. Plus 2 minus 2 will get cancelled. Answer is 2 root 2. So P of minus 1 is 2 root 2. Is it a factor? No, because we haven't got 0 as an answer. So again we can write, this implies R of x is not equal to 0. Therefore, by, always conclusion is must, by factor theorem, x plus 1 is not the factor of, write the whole equation, anyone, either this equation or this equation, up to you. X cube minus x square minus 2 plus root 2x plus root 2. Now children, see here, I actually simplified this. If you can ask me, teacher, without simplifying, if I substitute the value in the same given equation, is it okay? It's okay. There are some minus sign and that, be very careful in multiplying because x itself is minus. So to be very clear, I substituted. Otherwise, directly you can substitute as it is given. So there we complete this part. So this is how you are going to solve it. Check whether it is a factor or no. Remember, if the given expression is a factor, the remainder should be 0. If the remainder is there, it is not a factor. Two sums what we solved, both are not the factors. Check in the homework sum. You might get a particular sum where it is a factor because remainder would be 0 there. So please copy down this. We will start with the next one. The second question is, use factor theorem to determine whether g of x is a factor of p of x in each of the following cases. What does this question says here? Now see, polynomial chapter is very easy if you understand the question. If you fail to understand the question, you cannot do anything. We have to check whether g of x is a factor of p of x. How do you check whether it is a factor or no? If remainder is 0, it's a factor. Same questions, there are repetitions of the question. If it is not 0, then it is not factor. Again, the sums are very similar. So, second main in today's session for homework, this will be again first and third. Okay, so this was for first, second main, first and third one I am giving for homework. I am writing it very clearly. This will be there till the end of the session. So please mark in your book. Okay. So we will start with now second main, second one. What is it given? P of x is given as x cube plus 3x square plus 3x plus 1 and g of x is given as x plus 2. Okay, we need to check whether this is a factor of this. That means g of x is factor or no of that we have to check. So let us find the 0 of g of x. The 0 of g of x, that is nothing but x plus 2 equated to 0. Therefore, x is equal to minus 2. We need to substitute minus 2 in the given equation. So, I will write p of minus 2 is equal to x cube minus 2 whole cube plus 3 of minus 2 whole square plus 3 of minus 2 plus 1. Right? Minus 2, everywhere we have substituted. 2 cube is 8, negative number raised to odd power, answer answer is minus. Negative number raised to even power, answer is plus. So 2 square is 4, 4 threes is 12. 3 into minus 2 is minus 6 plus 1. Minus 8 plus 12 minus 6 plus 1. You simplify this. What are you going to get? You will get answer as minus 1, which is not equal to 0. So P of minus 2 is 1. Therefore, R of x is not equal to 0. So what we can write? Therefore, by factor theorem, whichever sums we are choosing, they are not equal to 0. They are not factors. By factor theorem, we will give the question conclusion only. G of x is not the factor of P of x. Is it very clear? So there we complete this part. Next one, it's only finding the value of k. Quite very simple. Third week we will start with this. You again have a homework here in the third week also. So third week you will take down first one and second one as homework. Okay, I am writing it on the board so that there will be no confusion. Please mark it. Third main, first and second I will give you for homework. Third part I will solve. What is this question now? They have given find the value of k if x minus 1 is a factor. They have already given that x minus 1 is a factor. So what should be the conclusion? If x minus 1 is the factor, then the given polynomial's remainder is 0. We know that it is confirmed. So let P of x be equal to what they have given, kx square minus root 2x plus 1, right, equal to 0 here. Okay. You want me to write it more clearly? I'll write that. I'll write it down so that it will be very much visible. I'll just write it here. P of x is equal to kx square minus root 2x plus 1 is equal to 0. I will write here equal to 0. Why have I written? Reason. Because what have they given? X minus 1 is the factor of P of x. This is given. Since it is a factor, the remainder is 0. That is why equate the equation to 0. So 0 of, because if we substitute the value, 0 of x minus 1 is equal to 0. This implies x is equal to plus 1. So wherever we have the x value, substitute it as plus 1. So P of 1 is equal to, right, once equal to, when we are equating it to 0 for the second time, actually we are not supposed to write 2 equal to sign the equation. But for writing it for once, we will write it. K of 1 square minus root 2 of 1 plus 1 is equal to 0. Next time, do not write equal to here. For equation, only 1 equal to sign should be there. So this is k square minus root 2 plus 1. So now you want to find the value of k square here, equal to 0, sorry. Next, k square is equal to transpose root 2 this side. This is going to be root 2 and this one is going to be minus 1. Okay. Now what we have to find the value here? It is not k square, children, it is kx square. Yeah. K into minus 1, I wrote k square here. We substituted, we got k minus root 2 plus 1 is equal to 0. So k is equal to, I transposed root 2 this side where minus became plus. I transpose plus 1 again this side, where plus 1 became minus 1. That is the value of k. That is what they have asked you. So from this one thing, you please understand, if in case they ask you to find the value of something and a factor is given, that means the equation is equated to 0, only then you can find it, right? So similarly, we'll be doing the next sum also. Please write it down. So the fourth sub question we will solve, that p of x is equal to kx square minus 3x plus k. Since the given thing is a factor, so equal to 0, we will write here, because this is a symbol for because x minus 1 is a factor of p of x. So 0 of x minus 1 equated to 0. So what is the value there? X is equal to plus 1. Since it was minus, you transpose that and make it plus 1. Let's substitute. P of 1 is equal to k 1 square minus 3 into 1 plus k is equal to 0. So k into 1 is k. So here minus 3 plus k is equal to 0. K plus k, 2k minus 3 is equal to 0. 2k is equal to, transpose 3 to this side, so that will become plus 3. So k is equal to 3 by 2 is the value. So that's the value of k. K value is 3 by 2. Yes. With that we complete the third way. So now factorization. You all know factorization, which you had in your standard 8. What do we do here? We factorize it by splitting the middle term. So let's first write down the homework section in factorization. So fourth main is factorization. I want you all to do in this second one and fourth one. Okay. So remaining we will do it here. So we'll start with, I hope you have copied this, right? Yes. So I'll clear this now. So let's clear and start factorization. Factorization is very important concept where you use that for your 10th standard also. So let's start. Fourth main, I'll start the first one in that. 12x square minus 7x plus 1. Okay. The first rule in factorization is, what you do here is always multiply first and last term. Always. What you get? 12x square into 1 is plus 12x square. As I told you, you have to make a working column, but this is not into a working column. This can be done beside that only, neatly. 12x square. Write the factors of 12x square. Always the first factor will be the number into 1. That is 12x into 1x will give you 12x square, of course. Always start with that. Next, try to get some more factors. So I can say 3 4s is 12. Right? Then 6 2s is 12. Any other terms wherein I get 12? No. 12 1s is 12, 3 4s is 12, 6 2s is 12. When we multiply all this, we get plus 12x square. But if you add and subtract any one of them, we have to get minus 7x. Right? So which is the number here which can give you the product wise 12x square and the sum or the subtracting part as 7x, that we have to see. First one we cannot, 6 and 2 also cannot, 3 4s is 12. 4 plus 3 is 7, but we want minus 7x. Minus 3 minus 4x will give you minus 7x. Minus 3x into minus 4x minus plus 12x square. So that is the right option to choose. So since we have to split the middle term, anything. Minus 4x plus 1. After this, we group the terms in pair. Between 12 and 3, 12x square and 3x, what is common? 3x is common. So, 3, 4s are 12x. 3x into 4x, 12x square minus 1. In factorization, always remember what you write here in the bracket, the second bracket always will be the same. Always. Now, I have written the same thing. Now try to adjust it. 4x into a what number should give you minus 4x? That is minus 1. Minus 1 into 4x, minus 4x, minus 1 into minus 1 plus 1. We got that right? Now group them. 3x minus 1. 4x minus 1. So this is the factorization, 3x minus 1 and 4x minus 1. We factorized it. Okay. Let's do similarly the next one. That is, I think fourth one is there. So third one we have to do it here. So third question is 6x square plus 5x minus 6. Rule wise, first multiply first and last term. One more thing children, please make sure that the polynomial is in the standard form, x square, x and constant. That's more important. If 6 is here and 5x is here, you can't be multiplying. The polynomial should be written in the standard form only. Ax square, bx and c. 6 into 6, 36x square. Write the factors. Always, we know that it will not come, but still 36 ones are 36. Then next factor is 6x into 6x is 36. Which else number will give you 36? 9 4s are is 36. This also will give you any other number? Yes. 12 3s are. There are so many factors. Write down 1 or 2 if you missed or something. That's okay. Just for our confirmation, these are the factors. When we multiply them, we get, okay, one thing, minus 36 you have to get. That's more important. Because it is minus here. So when I multiply, the product should be minus 36x square. When I add and subtract, I have to get 5x as an answer. First one we cannot, second one we cannot. 12 and 3 also will not give you 5. Only option left is this. Check. 9 4s are 36. Correct. I want plus 5. Plus 9 minus 4 will give you plus 5. If you change the sign, that will become minus 5 there. So 9 greater number, it is plus. 9 should be plus and 4 should be minus. So this is the right option. 6x square, when we split this, it is plus 9x. Again, you can write here minus 4x and this side 9x. That also will do. Minus 4x minus 6. We have done. Let's take common between these two. Between 6x square and 9x, what is common? 3x is common. 3 2s are 6 plus 3 3s are 9. Right? 3x into 2x, 6x square. 3x into 3, 9x. As I have told you, it's factorization. Whatever you write here, please write the same thing in the bracket. 2x plus 3. Now, 2x into what number should give you minus 4x? 2 2s are 4, minus 4x, minus 2. Check now. Minus 2 into 2x is minus 4x, minus 2 into plus 3 is minus 6. We got it? Group them. 3x minus 2, 2x plus 3. These are the factors. So this is how we solve the factorization part. So there we complete the factorization. Now we have factorization of a cubic polynomial. Now this was a factorization of a quadratic polynomial. Quadratic polynomial you have already learned in 8th standard. Again we have done this. Cubic polynomial is a bit different from a quadratic polynomial, but it's very important. Now let's see how to solve how to factorize a cubic polynomial. So the last main of today's session, fifth main, factorize. So this is factorization of a cubic polynomial. It is a bit different from the quadratic polynomial what we had done. So what we do here is, let us, yes, first of all, from 5th minute there's again a homework, 2 sums, second one and third one I have marked it for homework. So first one and fourth one will be doing it here. So these are the homework sums on today's session. Let p of x equal to x cube minus 2x squared minus x plus 2. So what we do here is, we have to find a factor for this particular given polynomial, and that goes by a trial and error method. So I will just write here, by trial method, right? Let x is equal to, see 0 we cannot start because 0 cannot be a 0 of the polynomial here. So I will start from 1. So I start from 1. That means I want to see that if I substitute 1 in this, whether this is a factor. That means I have to get remainder 0. If I don't get remainder 0, I'll substitute minus 1. If I don't get 2. If I don't get minus 2. Usually you need not go that much beyond 1 minus 1, the things are done. So let us do this by a trial and error method, where we try to find the factor for the given polynomial. So let us start first by 1. Let x is equal to 1. So p of x is equal to 1 cube minus 2x square, 1 cube minus 1 square, minus 2 into 1 square, minus 1 plus 2. So 1 cube is 1, minus 2, minus 1 plus 2, plus 2, minus 1 plus 1. Therefore, p of x is equal to, sorry, this is p of 1, right? Yeah, p of 1 is equal to 0. This implies we have taken x is equal to 1. So x is equal to 1 means x minus 1, right? X minus 1. If I equate this to 0, I get x is equal to 1. X minus 1 is the factor of p of x given polynomial. Is this very clear till here? It is the factor of a given polynomial. Since it is the factor of the given polynomial, so if you divide this by the given polynomial, the remainder should be 0 by a long division method. Now see here, till here what we have done, it is the common method what we follow. The next step what I am doing it is here, a different method what I am applying it to find. There are 1 or 2 methods for finding the zeros or factorizing this part. So I will be doing it by a long division method. In case if in your school they have adapted any other method apart from long division, if you feel that is easy, you can as well do it. Both are equally correct. So now what we will do here is, since we got this as a factor, let us divide this factor by the given polynomial and find the quotient of it. Once you find the quotient, we can factorize that quotient, which is a quadratic, and find the factorization factors. So let's do that. So let's divide this by the given polynomial. So this was the first step. So second step what I will do here is x minus 1. I will do that by long division. X cube minus 2x square minus x plus 2. What should be the remainder when I divide this? It has to be 0 because x minus 1 is a factor of the given polynomial. So let's start with the division. X into x square will give me x cube minus x square. We all are aware about division now, correct? So x cube and x cube will get cancelled. Minus 2 plus 1 is minus 1x square or x square minus x plus 2. Since it is minus, I will multiply this by minus. Minus x into x is minus 1x square minus minus plus x. Change the sign, cancel. Minus x is minus 2x What do you get the answer as? 0. That is equal to r of x. Therefore, quotient, that is q of x, is x square minus x minus 2. So this is subjected to now factorization. Factorize this to get the solution, because when you divide this, now this is a quotient. Though that quotient is nothing but the whole factor of this given polynomial. Okay, one factor we already found out. This is one factor. So another two factors, let us find out by this. So what do you do here? Rule wise, you multiply first and last term, that is nothing but 2x square. Factors of 2x square, 2x into x. You want this as minus 2x square. 2 into 1 is 2. You want as minus 1 here. So this is minus 2 plus 1. Minus 2 plus 1 will give you minus 1. So x square, split the middle term, minus 2x plus x minus 2. Take common, group these two and take common. Take x as common here, x minus 2. We all know that we need to write the same thing, x minus 2. X into what will give you plus x? Plus 1. So this is x plus 1 and x minus 2. So we got how many factors here? 2 factors for this. But this is a quotient for the given polynomial what we have divided, that is nothing but this. So a cubic polynomial will have 3 factors, 1, 2 and 3. The factors of, I'll just write p of x here, p of x are, so first it is x minus 1, next it is x plus 1 and the last is x minus 2, right? So these are the factors of the given polynomial. See, this is one method here, it is the common method. This is the method what I have done. You have another method by grouping it into factors and substituting it into the given polynomial. Now I have chosen this method. In case in your school if they try with a different method, you can as well adapt this or that. Both are equally correct. So this is how we find the factors of a cubic polynomial. This method is with respect to what you have in your standard 10, where we find the factors of a biquadratic polynomial. Now here you find it for a cubic polynomial. In your 10th grade you have a question where you find it for a biquadratic polynomial. We follow the same rule. With that respect, I have adopted this method. So this is how we factorize it, a very important question. So I've done the first one. Now I'll be also doing the fourth one. I want you all to copy this down. So in fifth main, fourth sub question, that is the last one for today's session. P of y is given as 2y cube plus y square minus 2y minus 1. By trial method, y is equal to 1. See, y only 1. I can also start by minus 1. But usually if you know, even in the graphical representation also, the first value we take always 0. Second value 1. Then minus 1. So let's go in the proper order. Let y is equal to 1. If y 1 doesn't satisfy, you can always go for minus 1. If not minus 1, then 2. So y is equal to 1. So p of 1 is equal to 2 of 1 cube plus 1 square minus 2 of 1 minus 1. So this is 2 plus 1 minus 2 minus 1. Again 2 and 2, 1 and 1 cancel, is equal to 0. So p of 1 is equal to 0. So since p of 1 is equal to 0, that means what? This is a factor. Therefore, y is equal to 1 is a factor. How do you write that? Y minus 1, when you equate, you get y is equal to 1. Is the factor of given polynomial, of the polynomial, okay. of the polynomial P of x, sorry, P of y, no it is, yes, P of y. Now what are we supposed to do? We are supposed to divide this by the given polynomial, and if you divide this factor by the given polynomial, what do you get? You get 0 as a remainder and you get a quotient. With that we factorize it. So let's divide y minus 1, you divide this by 2y cube plus y square minus 2y minus 1. So let's go for division. 2y cube plus y square minus 2y minus 1. So y into 2y square will give you 2y cube. 2y square minus 1 is minus 2y square. Subtract it, change the sign. 2y cube will get cancelled. Plus y plus 2y square, sorry, plus y square plus 2y square is 3y square minus 2y minus 1. Just bring the remaining terms down. 3y square. So I have to multiply this with plus 3y. 3y into y, 3y square. 3y into minus 1, minus 3y. Subtract it, change the sign. So 3y square will get cancelled. Minus 2y plus 3y is 1y. So this is y minus 1. Multiply this with plus 1. 1 into y, 1 into minus 1, minus 1. Change the sign. So y and y, 1 and 1. Remainder is 0. It has to be 0. Since remainder is 0, so now what this is equal to r of x. Therefore, q of x is equal to, sorry, it is not q of x. Always we are used to solve with the x variable, right? This is r of y. So this also has to be q of y. We always have x variable, so we get it as x. Q of y is equal to 2y square plus 3y plus 1, which you now factorize it to get the remaining factors of the cubic polynomial. So what we do again here? We multiply first and last term. 2y square into 1 is 2y square. Factors 2y into y. Plus 2y you want? 2 into 1 is 2y into y is 2y square. 2y plus y is 3y. So both are plus. So let us split this middle term. 2y square plus 2y plus y plus 1. Group them. 2y is common. Y plus 1. Here also it should be y plus 1. Y into what should give you plus y plus 1. So this is 2y plus 1 and y plus 1. Therefore, last term, these two are the factors of the quotient. Now that quotient is nothing but you got after dividing the polynomial, cubic polynomial. So what are the final factors of the cubic polynomial? Y minus 1, y plus 1 and this. The factors of P of y are 2y plus 1, y plus 1 and this y minus 1. So these are the three factors of the given cubic polynomial. So with this we complete this exercise. So the next one what we will be starting is algebraic identities. It's again the repetition what you had in your 8th standard. So there are few identities. I want you all to just brush up the identities once again what you studied in 8th standard. So tomorrow's session will be very easy for you. So again I repeat, please complete your homework sums, and any doubt in the class please call on the same day of the video set. It will be easy for me in addressing the doubts. I once again thank my students for calling and updating about the necessary changes which I had to make. Thank you once again. So any doubt in this, please call and